Hello, everyone, and welcome to the webinar. Uh, I expect people will be joining over the next minute or two, but because we have a packed schedule, I'm actually going to kick stuff off semi-immediately. I wanted to introduce my panelists, co-panelists, John Reese and Toby Weingartner. I will say, first of all, that I apologize for the homogenous nature of the panel, and I have sworn in the past not to take part in manuals, but due to various administrative difficulties and clearances and so on and so forth, we were unable to get this over the line at the last moment, and so I will be addressing the team here as gentlemen because there is only gentlemen, but next time will 100% be better, and my apologies for that up front. But anyway, John and Toby have a storied career in online services and IT in general, obviously, but online services, large scale systems, traffic management, names and logos you will have heard of and possibly even used. And I wanted to introduce each of them with a sentence or two myself and then let them explain a little bit about their own kind of personal journey. The first one I'll introduce is John, known universally as JGR in his time at Google. John, the first moment I met you, I was wearing a T-shirt that had 0100010001 and then the first number again, and you looked at it and under 1 second and said, "How many do you have?" Which I was impressed with at the time, and I'm actually kind of still impressed with it now. For those viewers who don't already know what that is, you decoded the binary into an ASCII string. Do you want to tell us about that?
Yeah, it's a DAD in all caps, or DAD. And I don't know, it's a skill I learned in my misspent youth.
Very good. Tell us a bit more about your career and what you're doing right now.
Well, I worked at various small companies until eventually spending bulk of my career, about 14 and a half years at Google, where I was for a lot of that time the tech lead of the traffic team at Google. I then left and went to Robinhood to form an SRE function there, and I am now retired from tech entirely, and I am a full-time in the sense that I'm full-time writer of fiction and nonfiction, and I have a particular project in the works that I think might be interesting to this audience, which is that I'm working with a colleague on a book and a blog, possibly more, about bringing blameless retrospective processes into our personal lives, like using retrospective or postmortem process on travel or home improvement or other sort of large projects where, despite our best efforts, things that are intended to make us happy often go wrong and drive us apart.
Very true. Do you have a URL or a link or anything for this yet?
We are about to go public with the website within the next week or so. If this is a topic of interest to you, though, you can email me, jtr@hindsightretros.com.
Very good. Okay, excellent. Toby, I don't think our first meeting was quite that dramatic, but you share one aspect of background with me, which is that you hung around a lot in kind of university computing departments in the aforementioned misspent youth that John mentioned earlier. Would you like to talk a little bit about that and then your later progress?
Sure. So my first university I attended was called Brandon University, a tiny little university in Canada. And then after that, I spent some time working in the States, followed by attending and working at a university in Canada. Again, sorry, University of Alberta in Edmonton. So I was there for like 14 years. And somewhere in between, completely forgot, I actually worked at ETH in Zurich for a couple of years. So working always as sysadmin, getting labs ready for computer science students, for researchers, things like that. And then basically in 2012, I sort of rebooted my career and moved to the Bay Area, moved to San Francisco. Joined Twitter at the time, helped them get through their IPO. And then after that, I joined Google, had a quick stint at DoorDash and went back to Google. And right now I'm actually on a traffic team. I'm part of the GSLB sub-team. So I'm in JTR's old haunts.
Very good. Excellent. I'm told that you enjoy career mentoring and equivalent activities. Is there any way that people can get in touch with you about this or talk to you about it?
Yeah, easiest way is just to find me on LinkedIn or most social media type things. I am Nutty Swiss, sort of similar to that. I basically talk with people. I have some presentations every once in a while I give to universities. Now that the pandemic has lifted a bit more, I'm hoping to get back to some of that. So if anybody has any places they want me to show up, by all means, reach out.
Very good. Thank you. So I'd like to talk about the general space a little bit, some war stories, and then some kind of Q&A. I want to tease some particularly interesting war stories around Java, every SRE's favorite language. I think we can all agree. And punishment beating of clusters, Chubby, and Zookeeper and related systems, and overload problems, as well as cache attacks. So there's a bunch of interesting war stories we talk about, but I think it's probably better to start off by reinforcing our commonly held ideas of the problem space and things that we can do in order to make traffic-related problems better, and RPC, retry communications, and that kind of thing. So let me start off by a kind of a general working definition of what we mean when we say traffic management, and so on. I mean, different competing definitions could exist in people of goodwill, and that's fine, and maybe we'll tweak some of them. But for the moment, I'll say traffic is kind of an action-causing, terminating application query, right? So something arrives in some sense on top of TCP or UDP these days, I suppose it could be. And this is interpreted at obviously at an infrastructural level, but at an application level, primarily through this lens. And so the machine is caused to do something by the receipt of the query. Sometimes there's additional queries thereafter. Sometimes this graph can be extremely complicated. Sometimes there can be interesting problems with the graph. You do not, in general, want it to be cyclic, and sometimes that happens. But anyway, I won't go, I think, in this webinar, I won't go into a lot of detail about how the traffic arrives across the internet, because there's actually a huge piece you can talk about there, particularly with respect to how kind of large-scale traffic steering is done, both, I suppose, today and in the future. Today, there's a wide variety of techniques like Anycast and DNS and so on, which I know from the Google perspective, but I believe a number of other, I was about to say Zaibatsu, large companies have very similar mechanisms as well. But basically, if we assume an internet and the traffic is arriving, we can understand traffic and queries and actions taking place within applications as basically being verbs and nouns, like HTTP verbs and nouns, in a kind of a point-to-point context, typically between services that go across a data center or a cluster. And you can also think of them as remote procedure calls like function calls. So instead of a single computer call stack, you have a multi-computer call stack. So basically, one of the major challenges when you have just taken a function stack which lived inside one computer and you could GDB your way up and down that and figure out what was calling what and how, when you smear that out across a network, you suddenly have a bunch of tools that are now missing or not applicable or might be way more complicated or might not exist. So that's one challenge to figuring out what happens in the world of traffic. But also you have a bunch of questions about reliability, which now emerge precisely because you've changed the single machine scope to a multiple machine scope. And so now a bunch of questions about designing for reliability hove into view. So, John, I'm wondering if you could talk a little bit about kind of traffic-focused concerns for designing reliability. What occurs to you in that context?
Yeah, there's a whole family of issues around too much traffic coming in and what happens to your system when too much traffic comes in. So if you have not written the system to be prepared, it will sort of by default run out of some resource, and that resource is often memory and might be CPU. Running out of memory is typically more catastrophic. If you run out of CPU, you slow down, and then if the load backs off, you may recover. If you run out of memory, you probably crash, right? You may also run out of resources like sockets or other sort of network level resources. And a lot of the best sort of like low level infrastructure for proxying and so forth has to be designed to withstand very high loads and be aware of what the resources are that it's protecting. It's also, especially with a proxy, it's important to realize that there are systems behind you that also may need to be protected from high amounts of load because they probably have different scaling characteristics. Probably like if you are just proxying HTTP requests, each HTTP request uses a relatively small amount of RAM, but if you're on the back end forging a giant HTTP response with pulling images and whatever in, that same request that was very lightweight of the proxy may be very heavyweight on the next server back in your stack. So there are sort of multiple layers of detecting and protecting against overload, knowing where your loose knobs are, where the resources that need to be protected are. And there's a lot of like stuff we can talk about there. I don't want to like completely delve into every aspect of it, but you can also, this can be both legitimate traffic, like you could just have what used to be called slash dotting, where like just your service is suddenly very popular because it went public in a way you weren't ready for. Another is that it could be an attack. SYN flood attack is a perfect example of a high traffic attack where they're just sending the beginning of a TCP connection, which requires your server to claim some resources because it's waiting. It needs to keep some state, wait for the next packet to arrive. If that next packet never arrives, it's just using up a resource very quickly. And yeah, so that's a broad category of risks.
Agreed. In terms of the state of the art with respect to what people actually do about this, I mean, the two big kind of terms I hear about are load shedding and circuit breaking. Can you talk a little bit about those?
Yeah, increasingly we live in a long past Web 2.0 world where we control the client as well as the server to some extent. We have either an app on somebody's phone or a relatively heavy JavaScript UI in their browser that's choosing to make requests to the server. In the old days, you assumed you had no control over the client because the browsers had nothing running in them and apps weren't really a thing. But that's nice because it gives you an additional knob to control load. So you can, for example, and I think this is generally called circuit breaking, you can start to detect if the request latency, if the latency from the server is going up, or if the server is starting to like, your server could start giving you little like warning signals like, hey, just going to like add an extra field in this response saying my queue length is X and X is above a threshold, or just like less granularly, just be like, hey, back off a little bit. And then, especially if you're talking about the client's background traffic, there are ways that you can like sort of gracefully reduce the load you're putting on the server without necessarily impacting customer experience. Circuit breaking basically says, okay, the requests to the server aren't getting through, so I'm just going to either reduce the rate or entirely stop sending requests to the server for a while until it has a chance to recover. On the server side, you can do something very similar. You can say, okay, I'm getting overloaded. I'm going to, if this is at the HTTP level that I'm getting overloaded, maybe I could respond with a HTTP code that's just like, 500 series, like a 503 error saying, I'm not currently able to handle this request. Feel free to try back again later. You can do something more nuanced, like I said earlier, where you do respond to the request, but you put in a field saying, please chill a little bit. I'm having trouble here. And if it's a very high throughput system, even accepting the connection can use up resources that you can't spare. So a network level proxy may want to do things like refusing to accept incoming connections once it reaches some certain level of resource saturation. Also, especially if that server has backends, then it is both a server and a client, so it also has the opportunity to implement those circuit breaking techniques when it talks to the systems behind it. And it's really important to realize that you're sort of on both ends of that all the time.
Yep. I mean, to that extent, if you grew up knowing about fluid mechanics, then a lot of those lessons would translate semi-immediately into the management of traffic as kind of a fluid or a substance, right? But
I've always thought that it was very interesting how in this field, a lot of the emergent properties start to look like other physical systems. And a lot of fluid dynamics problems and a lot of congestion control and overload problems are all very related. Really the internet is a series of tubes.
Let's not talk about overproduction of physics graduates or whatever. Anyway, never mind history graduates. So that's pretty interesting. My feeling is, and I mean, I have a bias in this very clearly, but my feeling is the state of the art out there with respect to the management of these problems is not very good. And if you, as a product developer, parachuted into Twitter or Robinhood or whatever, are they're like, I have this problem, what do I do? You are generally reaching for either something that isn't there or hacking something on top of an RPC layer. Does that resonate with you?
Absolutely. I mean, there are increasingly a lot of good tools out there, but you kind of need to know what the problems are to know what tools, what libraries to select and how to use them to defend yourself. So I really do think that sort of understanding the first principles of this is very valuable, at least for people initially putting the framework in place. Like if you're the intern who's hired and there's an already existing system, you're hoping that they thought about this stuff and you could just sort of like operate in a nice, cozy bumper bowling environment. But if you're the one who's responsible for setting it up, there's a lot of stuff you can do. Some of the most basic things that, I sort of jumped to sort of like the broad sweep, but circuit breaking, as I described it, is fairly nuanced, complex, advanced, much simpler. Retries, timeouts. So when you send a message, you should have a timeout on it, meaning after a certain amount of time, you're like, okay, that message was lost. I'm going to take some action based on the fact that it was lost. You shouldn't just assume that all messages are going to be received and acted on. That allows your system to make intelligent decisions in the face of failure. Retries are sort of a companion to that. If the message was lost, I may want to retry it, but you don't want to just retry it immediately, because if the server is overloaded, you've now increased the amount of load going to it, which is exactly what you don't want to do. What you want to do is have some sort of exponential back off and TCP protocol itself has this built in, but it's not that complicated to just say, okay, I lost it. My timeout this time was 1 second. My next timeout will be 2 seconds. Next after that, 4, 8, 16, etc. And that has much nicer properties in terms of reducing the amount of extra load that failure puts on the system.
Interestingly enough, I was speaking to a colleague the other day who suggested or who said that prime number fallback had been implemented in a company he was familiar with, because one of the things about exponential fallback is that it tends to smear all of the, or concentrate the retriers into a much smaller band. So when the system comes back up, you can get a thundering herd. But I want to turn to Toby for a moment. Toby, I understand you've spent a lot of time in the kind of RPC to service kind of interface area, and you're also somewhat experienced with kind of leader election, single point of failure avoidance kind of strategies here. So if you could talk a little bit about those or anything else that comes to mind with respect to the problem space.
So with respect to, I'll just mention this quickly. We've had a question. We're going to answer them a little bit later. So just in case you're itching to get an answer, we will get to them in a little bit. Feel free to post any other questions you have in the Q&A chat. So with respect to the interface between RPC and business logic, if you wish, one of the things that I've had the privilege or unfortunate experience of experiencing is that we do these type of things to reduce load, to excuse me, handle load. And one of the problems I've seen is that when your amount of resources that you need to expend to say no to something is bigger or more expensive than the thing you need to do, you're going to have a bad time. So, load shedding, circuit breaking, and any sort of mitigations, if you wish, telling a client to go away, come back later. All of those things need to be cheap, for lack of a better phrase. Not accepting a connection usually is fairly cheap, other than maybe the, resources on a switch or on a router or something like that. And usually they have to be orders of magnitude cheaper to do than what you're dealing with. So, yeah, that's about the best I can say with respect to RPC issues. So if you're marshaling or like changing the encoding, the response encoding, and that takes a significant amount of time. If you're allocating memory and memory is expensive. If you happen to be swapping or paging, that gets more expensive. All of these things, right? If you're doing them in the hot path of trying to mitigate some big denial of service or just being popular, you're going to make things worse, and you're going to end up in sort of a cascading failure, if you wish. Beyond that, I'll say something quickly about leader election and avoiding single points of failure. We're humans. We're not very good at doing things highly parallel, multiple events happening all the time. We tend to say, oh, we'll just, elect one thing, one leader, and then we'll have a single thing that acts on a database, on a data store. We know it's going to be done once. We don't have multiple things debiting an account twice. We just know this one actor that's going to be doing the thing, and it's either going to get done or there's an error and it won't get done, but we'll at least have one instead of multiple things. The problem we usually run into in this type of situation is that we can fairly easily usually detect that we don't have a leader, and we go through and elect a new leader. But detecting that a leader is slow or somehow otherwise degraded is very hard. It is, and anything you do to shall we say remove that leader from leadership has effects that could be negative, if you wish. where, well, it was just slow, but you have so much traffic, any other leader is going to be slow too. And now you're going to add in leader election into your, mix of just generally you're slowing down because you need more actors, not more leaders, so to speak. Having leaders also means that you can't do opportunistic retries or, things like that because you're going to talk to the leader, basically. You've got a single actor. And avoiding these leaders, if you can, is usually a more resilient system in the end. It is harder to debug. It is harder to know what exactly is going on sometimes. But in general, they tend to degrade better. So that's maybe the two things I can sort of touch on in this sense.
Very good. I think one of the difficult things about the traffic space in general is that the simplifying assumption that I will generalize terribly and say like 3 to 4 nines worth of developers make, which is that there is a socket, it delivers me some data. I don't have to worry about anything else. Turns out like not to be true in a number of really important kind of edge cases. And sometimes those edge cases are like everyday cases. So I think if I remember correctly in the gRPC stack, there's a thing where you can do early discard where you don't need to deserialize the whole thing. So you can just reject it early without mallocating a bunch of stuff. Toby, have you come across, or what's your sense of the capabilities of the stacks for doing this kind of thing available in the outside world? Like what did Twitter or DoorDash or whatever use?
So unfortunately, I did not get hugely involved in both of the stacks when I was outside. So Twitter, we had, now I'm drawing a blank.
It's Thrift, isn't it? Or is that
Yes,
Meta?
great. Thank you. At least when I was there, it was. I have no idea what current X or Twitter has. So, and then at DoorDash, it was gRPC. Um, we did, implement some circuit breaking things to help alleviate, shall we say, overload on backends and things like that. Tuning circuit breakers is hard. The code changes. That's part of the reason you have developers, and their behavior changes. So sometimes a circuit breaker set of parameters is good one way, but then a week or two later, it's maybe too optimistic or too pessimistic. And adaptive things are also hard to get right all the time. With respect to what do these stacks have, they all have means to, as far as I remember, to drop packets early or respond early saying, no, sorry, go away. Um, the more hammer-like thing, it would be to, close your listening socket for a while. Various things have implemented that from what I recall, but not necessarily part of the stack itself. It literally means that you now have a library that everybody links in, and you start having an RPC library that you expect people to use, not just what you get from GitHub or something like that.
Yep. And I think in kind of larger environments, consistency of implementation of these kinds of things is also in itself a problem because you made the library that everyone is supposed to use and like 65% of people use it because like they're busy. And now you get different retry behaviors across different service or even service groups. Yeah, so that's all very fun.
And one of the things I'll mention is that, if you're a smaller company or you're startup or you're doing your own thing type of stuff, you most likely don't have, the big manga fang, whatever company's problems all the time, right? A single machine or a couple of machines, database and front end, that sort of thing. And the framework that does most of the things likely will serve you well, right? Um, on the other hand, just because Netflix has it doesn't mean that you need it, right? Or whatever company, substitute your favorite engineering culture or company and their frameworks that they've got out there. So,
yeah. It's interesting though, and I'll touch extremely briefly on this because we have to move on to the next thing very, very soon. But for those folks with also a bit of a pipelines or data processing or ML background, as I have a little bit of, it turns out that traffic behavior also radically affects this, particularly if your traffic to your storage system has some trouble, then your pipeline system generally also has that trouble and possibly a bit worse. And so there's various techniques that people use to cope with that, including but not limited to, yes, paging on-call engineers, but also quarantine of processed units and so on and so forth. But as more and more people pile into the AI space and try and investigate this, that more organizations are having to become familiar with what it means to run a training process, which is essentially a crap ton of traffic to a storage system and a crap ton of traffic to a model assembly system of various kinds. Okay, so after all of that, it is now time to talk about the unexpected, the bizarre, the truly frightening, and the merely suspicious. I know both of you have been in traffic-related events and interesting outages in the past that have touched on some of the things beforehand. We've mentioned beforehand, I want to start out with every SRE's favorite language, Java. Note, this is a lie. I have no favorite language. But Toby, I understand you have an outage related to Java that you would like to talk about.
I don't know.
You have volunteered.
Java is my least favorite language, but not necessarily for this specific example. Now, that's hard to say. I haven't looked at all the languages. So anyways, this example is something, if you wish, bug that I found in almost every large Java code base I've ever had access to. You do a bit of searching and then you find out pretty quickly that this mistake seems to be there and fairly common. So Java has a date formatter function or library or something like that. That's, I guess, part of the sort of standard library. And one of the things that it has is the ability to say, YYY-MM-DD in a string, and it'll format that as, the year, the month, the day. But one of the things that's a little bit strange is that the M's and the D's will be in uppercase, and the Y's, well, if you put them in uppercase, you've got the wrong year. And this is something that not every even Java engineer seems to know. There's two different types of years. There's the calendar year we're all familiar with, which is all lowercase y's in the Java formatter. And then there is the year with week of year. So if you say, oh, this is week 1 of some year, week 2, week 3, all the way up to 52 or 53 in some years, I guess, or something, that's a different year, because at the beginning of the year, you span, unless you're really lucky, you span the new year, right? Part of the week is in the previous calendar year and part of the week is in the new calendar year. Now the question is, which year does that week belong to, right? Does it belong to the previous year or does it belong to this year? And basically, if more than half of it or something, there's a rule, I don't know 100%, but if more than half of it is in the previous year, it belongs in the previous year. So even though, Friday 2020 whatever might be in the new year, right? It actually belongs to the week of the last year, so the lowercase YYYs will give you last year's year. So anyways, many of the code bases have this bug, and you just grep for basically the date formatter with, followed by lowercase y's, and you'll likely find some. The outage we had was, sorry?
I'm tempted to ask why the standards committee felt it was necessary to hand out foot guns on entrance to the language rather than on application, but fair enough. Anyway, this did end up having a real world effect, as you're about to tell us.
Yeah, it actually did. So this was at a former employer with a bird. And basically, we were on call for the New Year's, which was an interesting event when I was at Twitter because certain countries and certain regions have cultures that say, you tweet a selfie and Happy New Year, and you're uploading well, the world is uploading pictures more frequently than before, and sometimes that caused a bit of an issue, overload, and so on. So, various SREs were on call for the New Year's. Happens to also coincide with a bunch of people going home for Christmas and, family events and so on. So I was one of the ones that basically volunteered to stick around and make sure things keep working. And funny enough, sort of on an hourly cadence, we started to see a bad situation develop where it was just before New Year's, actually, where the current week we were still in the old year, but the current week was now allocated to the new year because enough of it was in the future to be allocated to the new year. The other part was that several of our devices that our client ran on were not particularly good at keeping track of time. So they didn't use some GPS time base or whatever. They just sort of, took the time that you had and ran it whichever. So they drifted quite a bit. And we used this time as part of the request to understand, should we ask this person, this session, to relog in because it's a bit out there and maybe somebody took it over or whatever. It's not quite in the norm. So maybe we should tell them, sorry, you're logged out, and then they'll go and log back in and we resynchronize the time and for that device and we're good. Well, the other part was that in order to synchronize the time, what would happen is that for these particular small set of devices, the device would send what it had as its time, and then we would use that during the session with an offset. Yeah, they're this far behind or this far ahead or whatever, and they're still within the window. We're all good type of thing. Well, the way they got the time, since they didn't have a good time base, was to look at the time that the response from Twitter basically gave them, and then they basically used that as, hey, this is my time. What had happened in this case is that the request came in, the response came back with a year further in the future. So instead of being, December 2019 or whatever it was, I don't remember the year exactly. It was likely more like 2014 or something. It came back with 2015 in the response. It then would send back a response again later on with 2015, which was in the future, which our backends basically said, this is a little weird. We're going to log you out and basically send you to log back in. And we had our login authorization service sized for the usual traffic. Like, not everybody logs in all the time. That's not an experience you want to give to your users. We had enough traffic hitting that service that it instantly oomed. It instantly ran out of memory, and it was a Java service, Scala service, basically JVM based, and we couldn't even blink. It was out so fast, and it would try and come back up, and it was out so fast it wasn't even able to send any telemetry to say that things were wrong. It took a bit of debugging to find this problem, and we happened to see it. I was the unfortunate person who managed to recognize that, hey, wait a minute, that date's out of spec, and oh yeah, right, we're in this situation in terms of time frame. And did you all know that the ISO 8601 standard has this thing that, Java implements? And we all learned a lot that day. So yeah, that's roughly speaking how that outage went.
I was just going to say, it does sound like a bit of a punishment beating, which segues possibly into, John, you have a story from way back in Gmail early days, if I recall correctly.
That's right. I think it was around 2010 or so. And this is something that Google actually did publish a public postmortem for, although in the moment before this, I wasn't able to find it on my phone. If I do find it, I will share it. There was a sort of, if I understand correctly, and I don't have the postmortem in front of me because I am a retired person who no longer works at Google, but there was a gradual but dramatic organic increase in Gmail traffic to the point where it just barely had enough capacity to serve. At which point somebody took one of the several Gmail serving locations out for maintenance. The remaining locations did not have enough capacity to serve. They overloaded. They had that failure mode I described where too much load leads to too much memory, which leads to crashing. Every time one server crashes, the amount that needs to be served by the remaining servers is higher. So pretty quickly, they are all stably down. And the second one of them like dusts itself off, restarts, tries to get back up, it gets 100% of that traffic blasted straight into its face, right? So this was a major, it went on for a while actually before people got their heads around what was going on. I'm going to oversimplify here. Let's say there were 10 serving locations, each of which had 50 servers that could serve. So we had 500 servers worth of capacity. Our math said we needed more like 700 servers worth of capacity to serve. So somebody's like, okay, fine. All of our clusters are down right now, so I'm just going to expand this one from 50 servers to 100 servers. And I'll just do that at all the clusters one by one. The problem is the first cluster that tries to come back up is still trying to serve 700 clusters worth of load on 100 clusters, so it flattens again. So like stably, even the resized clusters, and to be clear, resizing clusters is not a fast process because you have to go out and borrow or buy resources. In a public cloud environment, you have to actually like spend the company's money. At Google, you have to beg, borrow, and steal from other teams. Some teams would have to say, okay, fine, I haven't launched yet. You can have some of my capacity for now. Like it's a zero-sum game. You have to negotiate for existing resources. Anyway, so like once they had acquired the resources, they still couldn't come back up. So the thing that they had to do was to direct 100% of that traffic to a single serving location, basically just pummeling that one location, and then let the other 9 rise back up 9 times whatever 100 is greater than 700. So once they were all up, they were able to start trickling the traffic back onto the now living servers, at which point they're able to get enough load off the sacrificial cluster that they could bring the sacrificial cluster up. But this is a technique that like was not well understood, and it requires a leap of faith because piecewise, you always want to save your servers. So the idea of like pummeling servers, even if they're already down, it's a hard leap for a lot of people to get over. So it was, for me, it's a great example of like why you sometimes have to consider the Gestalt situation and not the local situation in order to make a small sacrifice so that the larger system can restabilize.
Yeah, very much so. I mean, it's so interesting. I mean, first of all, from the point of view of kind of cascading failure models, but also the slightly humorous idea that there's this sniper, and as soon as somebody sticks their head above the parapet, you're like bang, thunk, and so on and so forth. So it was a very illustrative outage as well because it forced you to think about clusters or servers or whatever as scapegoats rather than the humans as scapegoats, which is usually how it goes. In view of the time, we could talk about so much more, but in view of the time, I want to get to some questions super quick. The first one from Sarah Murphy. Hello, Sarah. is basically saying these days, most engineers who are dealing with traffic of some kind or other have way fewer knobs and levers because most of their stuff is running in the public cloud and other teams are responsible for that. How does this play out today? John, I think I might ask you to come in on this.
So there's a joke and sticker that says there is no cloud, it's just other people's computers. And while that is true, I think it also implies the wrong message. I think it actually is really good that we have these this separation of concerns where people who are expert in running large scale network load balancing are responsible for that so that other people can focus on their application behavior. That said, your customers don't care whether the failure is in your application or in the load balancing layer. So I think there needs to be a sort of, your system needs to be monitoring end to end as if customer traffic. So this is what we call probers or something. You need to have traffic that simulates a full customer journey from as much of the infrastructure that you don't control into your own system, make sure that behavior is as you expect it to be. And I think not everybody at your company, but some people in your company do need to understand enough about what the infrastructure is doing that they can have meaningful conversations with that infrastructure provider when things are not working, and being able to say, you know, like, look, I'm seeing TCP resets from inside your system, or because I'm this or that thing is happening, I have some idea that your system is not behaving as spec. You can't 100% draw the line at the boundary of your system. That said, I still think this is a better situation than everybody having to vulcanize their own rubber. So
true enough. Toby, I have a unrelated question for you, I suppose, which is mandated by law. I mean, I don't make the rules, but the question the law requires me to ask is AI going to change any of this?
You're asking the wrong question. So I personally don't have a particularly favorable view of the current AI landscape. Having said that, I am no expert. I know very, very little about it. I worry about its negative impact that it can have, and you know, that's a worry I have with respect to AI and sort of this space, if you wish. I think that AI will end up being a little bit like the laser. So or even if you wish, the microwave. I Really quick story, when my family got their first microwave in early 80s, if I remember right, or mid 80s. You know, we got this new machine in, you know, supposed to cook stuff and everything else. And, you know, hey, mom, you can now use a microwave to cook stuff. And she tried to make a cake, and that did not work because we did not know what that particular tool was good for. What it was really good for was warming up food, you know, the second or third time and making hot water for coffee. Like, that's what our microwaves were really used for early on. Similar with a laser, right? When laser first came out, nobody really thought, oh, we're going to use this and revolutionize communications so much as in, oh, Star Wars, we're going to like shoot missiles down or, you know, cut really, really anything with it and so on and so forth. And some of that has come to fruition. You know, lasers are used to cut quite a number of things, steel to wood to fabric. But a good chunk of it was not something we ever really envisioned as a broad thing. And I think AI is going to be in a similar fashion, at least the current AIs, if you want to call them that. I think we're attributing things to them that they will likely be very poorly suited for. And we're likely missing out on the things that they will turn out to be really good for. And I'm curious what that second part is going to be. But I have no idea. If I did, I think I'd be really rich, but So
Fair
hopefully
enough.
that answers your question.
Really, really rich or well-funded, I think, are the two
Yeah,
possible
well,
states.
there is that.
Can I interject?
Sure.
Sure.
I am also an AI skeptic. My experience is that it doesn't do the right thing often enough that you can trust it on its own for many applications. Where I have seen it used is in cases where the consequences of a false positive, false negative, whatever direction it fails in, are manageable, and at scale, the amount that it's doing, the good outweighs the bad. An example of that would be DOS attack detection. So we used a machine learning system at Google that sort of identified traffic patterns that looked attack-like. And if your traffic looked attack-like, it would say, hey, if you are a human and not an evil robot, solve this CAPTCHA. And that would, so there would be a escape hatch if the machine learning system got it wrong. I still feel like that's we're in the space of like either the unattended system has to have an override, or it needs to be a magnifier for the skills of an individual, but like everything still flows through that individual. I don't think we're in safe to leave unattended AI systems for the most part.
Fair enough. Absolutely. I think I have a complex personal view, but to the extent that statistics plays a role in AI, statistics can play a role in traffic management for sure. So that is indisputable. Anyway, we are super over time. Thank you very, very much, gentlemen. I really appreciated it. Not just gentlemen next time, I swear, I promise. But thank you very much for your time. An honor and a privilege. And I hope folks attending learned something. And we'll get the recording out as soon as we can. All right. Bye-bye, folks.
Bye.